Lesson 4.4 is about factoring. We're going to factor trinomials and binomials in various forms. It would be helpful if you could remember how to multiply binomials. So we'll just review that first. If we want to multiply these things together, we will FOIL. If you remember, FOIL stands for first. F stands for first, O stands for outside, I stands for inside, and L stands for last. So we're going to multiply the first times the first and get x squared. Multiply the outside two variables or values and we get 2x. Then the inside gives us 4x and last gives us 8. And then we can combine like terms in the middle. We get x squared plus 6x plus 8. Okay, and you can try it here with the second one. And that's what you should get with the second one. So now we are ready to factor. Factoring is the opposite of FOILing. So we're going to take an expression like this, and instead of multiplying, we're going to divide, and we're going to end up with an expression like this. So factoring is exactly the opposite of FOILing. Okay, so our first expression here is x squared plus 9x plus 20, and we're going to factor it, so we're going to end up with two binomials. To figure out what goes in all the different positions, we'll start here at the front, and we're going to divide that up into two pieces. So we're asking ourselves what times what would equal x squared, and it's going to be x times x. X times x is x squared, so those go in the first positions. Next, we will look at the end here to figure out what goes in the last positions. So looking at the 20, we want to make a list of all possible ways to multiply two numbers together to get 20. So 1 times 20, 2 times 10, 4 times 5. That's every possible way to make a 20 multiplying integers together or whole numbers together. So of these three choices, which one adds up to 9? Well, 4 plus 5 is 9, so those will be the numbers we want. Put a 4 here and a 5 here. Now, if you FOIL these two binomials, you should get this trinomial. So let's just try it. X times x is x squared. X times 5 is 5x. 4 times x is 4x. Adding those together, we get 9x. And then 4 times 5 is 20. So yes, it does work. Okay, next one. We're going to factor this into two binomials. We know x times x is x squared, so we can start with that. Now we're making a list of what multiplies to make 72, but 72 is not a positive number, it's negative. So what multiplies to make a negative 72? Well, we have 1 and 72, where 1 could be negative, or 72 could be negative. We have 2 and 36, where 2 could be negative, or 36 could be negative. And we continue this list. Okay, there's our complete list. And then we have to pick the one that adds up to a positive 14. So positive 14 would be negative 4 plus 18. So we would factor this as x minus 4 and x plus 18. Okay, in our third example, we have a leading coefficient that's negative. This is never a good thing. So the first thing we'll do is factor out a negative 1. So that gives us a positive x squared, but we're factoring negative 1 out of the entire equation. So the positive 13 becomes a negative 13, and the negative 12 becomes a positive 12. And now we can factor this, keeping the negative in front, and then we'll have two binomials. So x times x is x squared. Making a list for 12, we're going to have 1 times 12. If it's positive, we only have to consider the positive choices. 2 times 6 and 3 times 4. So the one that adds up to 13 is 1 and 12, but it has to add up to a negative 13. So if we had a negative 1 times a negative 12, it would equal positive 12 when multiplied and negative 13 when added. So that's the one that we want. So there we go. Here are some problems for you to try. Hit pause while you try them, and when you have answers, hit play. Okay, we're looking at factoring some more, but in this case, we are factoring out a greatest common factor. So in this first example, it's not even a trinomial, so we can't really factor it into two binomials, but what we can do is factor out a GCF, or a greatest common factor. So our greatest common factor here will be whatever number goes into 6 and 9, which is 3, and whatever variable will go into n squared and n, so that would be n. So if we're going to factor out a 3n, that means we're dividing by 3n on each of these terms. So 6n squared divided by 3n is 2n, and 9n divided by 3n would give us just 3. Now if we were to distribute the 3n into this factor, we should get 6n squared plus 9n, and we do. So that's factoring out a GCF, or a greatest common factor. This bottom one is a trinomial, but since each of the parts is divisible by 4, we should factor out the 4 first. So 4x squared divided by 4 is just x squared. 20x divided by 4 is 5x. And 56 divided by 4 is going to be negative 16. 14 here. Okay, now that we have the GCF factored out, this trinomial that remains can be factored further, or at least we should try to factor it further. X times x will give us x squared, and then what gives us negative 14? Well, 2 times 7 is 14, but to make it negative, one of the factors has to be negative, and this top one will add up to 5, so we can factor that as x minus 2 times x plus 7. So there it is in fully factored form. But you should always factor out a GCF first. Here are some problems for you to try. Make sure you factor out a GCF first on each one, and then with what is remaining, try to factor it further if it's possible. Hit pause while you work, hit play when you're done. Actually, that'll be the end of this half. We'll go to the second half when you're done.